some catalyst, nickel, palladium, platinum. Direct hydrogen, or you can take NaBH4 or LiLH4. Got it? That's what we had seen. And I also compared the reactivity of sodium borohydride and lithium aluminum hydride. Lithium aluminum hydride was more reactive. So it was able to reduce aldehydes, ketones, esters, carboxylic acids, all of them. While NaBH4 was able to reduce only aldehyde ketone. And we took other examples also. This is a carboxylic acid. Okay, so carboxylic acid, who will reduce carboxylic acid? Who can reduce carboxylic acid? LiLH4 can reduce carboxylic acid. Got it? NaBH4 can't reduce carboxylic acid. It can reduce only aldehyde and ketone. So look here, we have kept the carboxylic acid same untouched, and we have reduced the ketone with NaBH4. But with LiLH4, that was more reactive. So we reduced actually both of them. So this I hope is clear to you. Any doubts on this? Esters upon reduction will give 2 alcohols. Is it clear to everyone? Aisha, am I audible? Leslie. Okay. So this is the method of preparation of alcohol by reduction. Okay. Let me move to another method. And that method is using Grignard reagent. So first of all, tell me how this Grignard reagent can be prepared. Any idea about it? Ibrahim, Jesslyn, Marwa? Aisha, any idea? How can we prepare Grignard reagent? What were the methods which we have seen in alkyl and aryl halide chapter? Tell me quickly.
Reacting an alkyl or halide with magnesium metal in anhydrous ether.
Yeah, exactly. Magnesium in the presence, you first prepare alkyl halide, right? And you react the alkyl halide with magnesium turnings in the presence of ether, dry ether, because we should not have water in it. Otherwise, what will happen? If you have water, then the magnesium will react with water and it will not be able to react with the RX. And on the other hand, your Grignard reagent will also get spoiled with the water or moisture. Is it clear to everyone? Okay, so that's good. So how to prepare Grignard? Suppose if we have CH3Br. Okay, And if you have CH3Br, you can heat it with magnesium. You have pieces of magnesium turnings, okay, small pieces of magnesium available in the lab, and you put some ether because you need to dissolve both of them. Ether can be diethyl ether, or you can write just ether, or you can write the formula of the ether, C2H5 whole twice O, or you can write THF. Okay, these are the ethers which are used for dissolution purpose only. Okay, and you will end up with CH3 MgBr. Got it? This is the Grignard reagent. So from alkyl halide it can be prepared. Okay, and I told you one thing, Aisha, Marwa, Jasleen, in Ibrahim, in that alkyl halide chapter also I told you that what is the in order to understand the reactions given by Grignard, you need to understand what are the charges is each atom is carrying in a Grignard reagent. So Grignard actually, this, what is the charge on magnesium? Yeah, Ibrahim, what is the charge on magnesium?
The positive Mg plus.
Yeah, it is normally it is +2, yeah, but it is actually bit covalent, so this is positive charge because it is a metal. Okay, this is negative, and carbon is negative. So if you have a Grignard reagent, consider the negative charge on carbon. Okay, this is the main thing which is important for us to understand. Is it clear or not? Consider the negative charge on CS. Got it? All your problems will be solved. So suppose if you react it with water, what will happen? Water is what? What ions are present in water? Aisha, Marwa, Jasleen, tell me.
OH minus.
It is H plus and OH minus. Got it? So what will happen to my Grignard? Any idea? What will happen to my Grignard reagent? Yeah, tell me. This is plus and minus. So CH3 minus will react with whom? OH minus. Minus minus, do they react with each other? Tell me quickly. They don't react. Okay. So who will react with whom? H plus will react, okay, with CH3. So you will end up with CH4. And what will happen to that OH minus? That OH minus will react with Mg. Is it clear or not, Ibrahim, Jasleen, Aisha, Marwa? Is it clear to everybody?
Yes.
Yes, sir.
Very easy. Just you think of like this. You can write it like this. Okay. You don't need to remember it. Just you know that magnesium is a metal. Metals are electropositive. With that, you can start your reaction. Okay, because this is the reaction of the alkyl group carbon. So H plus and OH minus. So how am I going to connect with each other? Got it? Is it clear or not? So now this H plus is being connected to CH3 minus, Mg plus is being connected to OH minus, right? Like that. So you will end up with a methane. So somebody may say that suppose how can I prepare? How can I prepare alcohol from grignard? Is it by putting water? Yes or no? If I
Yes,
want
sir.
to
We can add
prepare
water and we'll get.
alcohol from grignard, is it by putting water, Ibrahim?
Yes, I think if we add water to this, we might
Just
get an alcohol. I think.
And normally it appears like this, that when we add water, water has OH and you are going to end up with alcohol. But this is not the case. Look at this. What is that? So my question I am going to repeat once again. Jasleen, Marwa, Aisha. My question was, will I get water? Okay. Oh, sorry, will I get alcohol upon putting water with the grignard? When grignard is reacted with water, will I get alcohol or not? Tell me quickly.
Sir, no.
We will not get alcohol, we will get alkane. You can see here. Is it clear to everybody?
Yes, sir.
Yes, sir.
Oh. So if I put water into the grignard, I will get alkane. This will be useful in your chapter of alkyl halide also. It was there. Okay. I will not get alcohol. Ibrahim, is it clear or not?
Yes, sir.
Got it. But if I react grignard with another aldehyde or a ketone, I can get an alcohol. Suppose let's start with the reaction with CH2 double bond, or this is the formaldehyde, or methanol, the smallest aldehyde. Okay. So what will happen if I react the grignard with this? What will happen? Tell me. So just think of the charges. Is it clear? What was the charge on CH3? It was minus, Mg was plus. So just attach the charges in opposite manner. Okay. So what we are going to end up with? Is it clear or not to everyone? How to solve this problem? Just try to look at the charges on the grignard and on the substance which is given to you. Right? So Ibrahim, can you help me out to write the final product? Yeah, Ibrahim.
So we get CH3, CH2.
Hmm.
Yeah,
this
that will go
yeah.
there.
Hmm.
Plus MgBrO. Does that exist? Yeah, MgBrO.
Yeah, exactly. CH3, CH2, this O will become minus and MgBr is plus. Right. Very good. But we need to get an alcohol. So we are very close to alcohol because we already have a single bond. Just put water. Is it clear or not? What you will get CH3, CH2, OH. And what will happen to that Mg? Because water is H plus and OH minus. Is it clear? Any doubts on this? So let me take another example. So Aisha, Marwa, we can try this one. Okay. Let's say, suppose if you react this CH3 MgBr with this ketone. This is acetone, which is a common name of propanol. What will happen? So this is plus because oxygen is minus. This is CH3 minus Mg plus. That's what we need to know and connect them. This is nucleophilic addition reaction. This is a nucleophile. It is a negatively charged species, the Grignard, the carbon. It will attack on the carbon delta positive, and the O will get attached to magnesium. Got it? So what we are going to get? What intermediate we are going to get? Two methyl groups were already attached. Got it? One more I attached. On the pi bond. You have oxygen. That will form minus. And that will get connected to MgBr. Now we already have the single bond oxygen. How to get an alcohol? What is the last step which we need to do? Aisha, Jaslin, Marwa, tell me what is the last step? React it with water. That O minus will become OH. Got it? Clear or not? Any doubts on this? Just you need to look for the positive and negative charge on double bond. So when you react aldehyde ketone with Grignard, you get an alcohol. Okay. Let's try some problems and tell me which alcohol are we going to get. Okay. Or this is phenyl. So let's do this problem quickly. Aisha, Marwa, is it clear to you? The question? Can you see the question? So, what will be the products formed when methyl magnesium bromide is going to react with PHCHO, which is the benzaldehyde? I hope everybody is able to see the question which I have written. I can help you out. This is minus, this is plus. Okay, magnesium is plus, so CH3 is minus. And in the reactant which is given, this oxygen is minus and the carbon is plus. Got it?
Yes.
So this I hope is clear to you, Aisha. So just try this first one. What I need to do? Who will help me out to write the product? For the first one. Tell me quickly. This carbon is negative charge and this carbon is positively charged because it is connected to oxygen. Yeah. So tell me quickly. What is the first thing which we are going to make? This carbon I'm going to attach to the carbon of the double bond. Ibrahim, are you getting? Marwa, are you getting or not? So this phenyl, this is benzene ring. Okay. CH. You put CH3 here and oxygen is there. Oxygen will become O minus. You put magnesium. Now, if I react with H plus or water, this O minus will become OH and it will become an alcohol. What type of alcohol we got? Is it the primary alcohol, secondary alcohol, or a tertiary alcohol? Quickly tell me.
The secondary.
Yeah, secondary alcohol. So this is an aldehyde. So we ended up with secondary alcohol. And this is a ketone, cyclic ketone. Okay, double bond O. This carbon is having a plus charge. This is having a minus charge. This carbon group ethyl magnesium bromide is having a minus charge and this magnesium is plus charge. Okay. So what we are going to do? Where we are going to put this ethyl group? Ethyl on this carbon of C double bond O, right? Got it? Once the ethyl group is connected, the double bond will become single bond. Got it? So ethyl is placed on carbon and MgBr was placed on oxygen. Is it clear or not? So you will have OMGBr. Okay, and you have a cyclohexane ring that is going to remain as it is. And I'm going to place ethyl group. Is it clear or not? Tell me, everybody, frankly. Will you be able to do it in the exam? I want to hear from all of you. Will you be able to do it? Because this is a very, very important reaction. Okay. But very simple. The carbon of the grignard is negative and aldehyde ketone is C positive because it is connected to oxygen. Okay. So just connect the carbon by looking at the charges. Opposite charges need to be joined together. And then you can react with H plus H2. So you will end up with OH. Is it clear or not? So this is a ketone and we ended up with if I give a ketone or if I give a final alcohol, tertiary alcohol, you need to tell me which ketone and which grignard do I need to take. Okay. This alcohol is having three groups, one methyl, ethyl, and propyl. So what set of grignard and ketone need to be taken to get this alcohol? Tell me quickly. Ibrahim, are you there?
Yes, sir.
So just help me out. I want you to tell me one grignard and one ketone, which I need to take to get this alcohol, which I have written over. I hope you understood my question. So just tell me which grignard and which ketone I need to take.
So maybe we can take what? CH3 CH3 CH2 no CH3 CH2 MGBR, I think.
MGBR, okay, or MgCl also you can take, okay, yeah, good, or MgI also you can take, that is good. And along with that, so this are taken with grignard, got it? That's what you meant, Ibrahim?
Yeah.
So
And then the other
which,
one we can take it as a
yeah, which
ketone, the upper chain, the middle chain.
yeah, that
CH3.
upper part I can take as, yeah, so CS3.
Yeah.
Yes, exactly. CS3, CO, got it?
C
Make it
C
CO.
double bond O, CH2 CH2 CH3.
Yeah, exactly. Very good. Just you can mix them together and put water once after adding grignard, not before that. Once you react with grignard, then next step, write H2 or H plus, okay, to make it OH. So very good. And what could be the other method? What other method we can have? You have taken ethyl magnesium bromide. Can we take methyl magnesium bromide?
Yeah, I think. Yeah. We can take that also. CH3 MGBR.
Yeah, we can take that also. Exactly. Okay. So if I have taken this, what should be the ketone?
Then the The remaining thing, yeah.
Yeah, the
C-
remaining part. Yeah,
No.
this whole, this
Yeah,
part,
yeah, yeah. The remaining part. Yeah.
that can be taken.
C double bond O, CH2, CH3, and
Yeah, C double bond on one side, you have a propyl group. Marwa, are you getting my point?
Yes, sir.
Yeah, if anything is not clear, do stop me any number of times, okay? I will explain it, right? Or there is one more option. We have taken this as a grignard and the remaining part as a ketone, this as a grignard and the remaining part as a ketone, or what else we can do. Now we are left with this we can take as me. Got it? This, if we have taken this as a grignard, the remaining part will be taken as a ketone. Is it clear or not to everyone? Don't make a mistake, Jasleen, right, in this? Because this is a very important part for all the three upcoming chapters, not only for alcohol ethers. Okay, so we made this alcohol, this tertiary alcohol, by taking different sets of grignard and ketones. So, Aisha, is it clear? Jasleen, any doubts in this? Mara,
Yes, sir.
okay, good. Now, this one more extra information about this grignard is that they come under the category of organometallic compound. As they contain carbon metal bond. Metal being magnesium. Got it? So this I hope was clear to everyone. Now, so this is about the preparation of aliphatic alcohol. We can discuss the preparation of aromatic alcohols. Can you give me example of aromatic alcohol? So let's look at the preparation of phenol. Okay, we need to entirely discuss it separately because that is having entirely different properties. Is it clear? Preparation of phenol. So any idea how to prepare phenol? Some methods we discussed in reactions, not as a preparation, but as reactions in alkyl aryl halide chapter, haloalkane, haloarine chapter. Any idea? Ibrahim, if you remember any of the methods.
So from chlorine, NaOH and HCl we can get OH.
Yes,
phenol.
exactly. And what that process is known as?
From Halo Arencia.
Yeah, from
Formation from
Halo,
Halo.
Dawes process, right? So you take halluarine, chlorobenzene, okay, and will the reaction happen easily or will it happen with difficulty? At what we discussed earlier. Will it happen easily or with difficulty?
Because it needs some temperature. Yeah, I think 623 Kelvin. I think.
No, but will
About
it happen
3
easily or with ease or with difficulty? What do you?
Wait.
As far as
Yeah.
reactivity, if I ask you to compare, will they be more reactive or less reactive? Will it be more reactive than normal haloalkane or less reactive? It is going to be less reactive. Why? What is the reason? Marwa, Jaslin, can you tell me the reason why the chlorobenzene is less reactive than normal chloroalkanes? Jaslin, Marwa, Aisha, what is the reason behind the less reactive? Tell me quickly.
So is it because of the resonance structure?
The screen has gone. Yeah. So is it chlorobenzene? Is it more reactive or less reactive? Yeah. What was the reason? More or less?
Less
Then,
reactive?
then I'm comparing with respect to normal haloalkane. Yeah, more or less. Yeah, Aisha, Marwa, tell me quickly. It will be less reactive, Ibrahim, because there is a there is a bonding or resonance happening between this loose electrons, unpaired electrons with the pi electrons, due to which the chlorine and carbon form extra double bond, and which makes the removal of chlorine from benzene difficult. Is it clear?
Yes.
So just uh, be careful about it. Very, very important. Okay. That what chlorobenzene is less reactive. So Ibrahim, in order to overcome this less reactivity, if something is less reactive and if we want to react, what you will do? You will heat it. Okay. And you will apply high temperature and pressure. Got it? It will be replaced by O because it is NaOH, so it will form ONA. Then you will react with some acid or water to make it phenol. Is that clear to everyone? This is the Dawes process. Okay. bimolecular nucleophilic aromatic substitution, but it requires more vigorous condition than the normal substitution reaction because of the vigorous conditions. Okay. High temperature and heat. Okay, it requires 350 degree and 300 atmosphere. Next process is so Ibrahim, could you read it out for me what this process is?
From benzene sulfonic acid.
Sulfonic acid. What's the formula for the benzene sulfonic acid?
What? I think NaNO2. NaNO2.
No, sulfonic acid is SO3H.
No.
Like
Benzene ring plus NH2.
no, not NH2, that is aniline. Sulfonic acid. Carboxylic acid, sulfonic acid, right? This is the sulfonic acid. So how we are going to get it from benzene, first of all? First, we need to get it from benzene, convert the benzene to benzene sulfonic acid by heating it with concentrated H2SO. You can remember it in this way. This is benzene. And this is H2SO. Right? Remove water. Is it clear or not? This is benzene sulfonic acid. Now, if you need to convert it into alcohol, what you need to replace by whom? Aisha Marwa, tell me what we need to replace and by whom?
So
We need to replace, yes, tell me,
SO3 with
SO3H by OH. So react it with NaOH. Got it? Yeah. This concentrated H2SO4 and SO3 is also known as oleum, right? This one. Aisha has already given the answer. I've seen it just now, oleum, and the formula is H2S2O7. Okay, it's 2 sulfuric acid with water removed. Okay. So once you have this NaOH, this OH will come in and it will form ONA. Removing the SO3H group, you can take H plus H2O or HCl, that will convert the ONA to OH. So I hope this is clear to you. Got it? This is how the benzene sulfonic acid is converted to phenol. This is the same reaction. Okay. That reaction is nucleophilic aromatic substitution. Got it? And the next method is So what is this benzene diazonium salt? Can you tell me? Or diazonium salt, aryl diazonium salt, or benzene diazonium salt? What's the formula for it? Ibrahim, tell me quickly. Aisha, Marwa, tell me. What's the formula for benzene diazonium salt? Yeah, Ibrahim. Aisha, Marwa, Jesslyn, tell me quickly. We have seen the salt in the previous chapter. So just try to decipher its structure, what its structure should be. From the name, there is a benzene.
N2 and Cl.
So benzene ring is there, and what else is there? What else is connected to
NH2, I
benzene?
think, yeah.
What
NH2.
NH2?
I think, yeah.
Okay, that is the reacting material. Okay, that's from start the preparation of benzene diazonium. Benzene diazonium is benzene, and who else want to answer it to me quickly? Marwa, Jesslyn. Yeah, N2 plus. Right, correct. N2 plus. Got it. So this is N2 plus and some salt because it is a plus, so there should be some minus, X minus. This X minus normally Cl minus, Br minus, I minus, it depends upon the acid, or HSO4 minus also. It depends upon the acid which you have taken. Okay. For the preparation, and it is prepared from aniline, right? This is how it is prepared. Is it clear or not? And how you are going to prepare it? By reacting it with NaNO2 plus HCl by keeping low temperature, because this salt is unstable. So you need to keep the temperature between 0 to 5 degrees Celsius. If it is Cl, then X is Cl. If it is acid which you have taken is H2SO4, then it is HSO. Got it? Is it clear to everyone? Any doubts in this?
So
Okay. Now you have N2, and that can be replaced easily. It is unstable. Okay. So you heat it with water. So Ibrahim, what will happen when you heat it with water? The water OH will come in and N2 will go out. Got it? Very, very important. And this is benzene diazonium chloride or salt, benzene diazonium bromide. It depends upon the acid which you have taken. Okay, we have seen various other methods also for the preparation of bromobenzene, chlorobenzene. We have seen Sandmeyer Getterman in the previous chapter we had seen. So suppose if you want to convert it, so just quickly recap, I will ask two more things. If you want to convert it into chlorobenzene, what method do we need to employ? This is from the previous chapter, just a revision. And if you want to convert it to bromobenzene, what we need to take? This is Sandmeier's. Got it? Or you can take copper plus HCl. That was Getterman. If you take only copper, that is Getterman, and if you take CuCl, that is Sandmeier. Same with the case of Br also. Is that clear to everyone? These are from the previous chapter, but very, very important for you to remember the names. Yes, Aisha. Yeah, with copper it is Getterman, correct? And with CuBr and HBr it is Sandmeer. The names are different, but the purpose is same. Okay, so you can get back to from aniline. You can get chlorobenzene, bromobenzene, and that's what the preparation of haloalkane, haloarine in the previous chapter which we had seen, and this is the preparation of phenol. Got it? So this I hope is clear to all of you. Very, very important. These two reactions are from the previous chapter, but we were just about close to that topic, so we have discussed it. So this is the preparation using sand. Now, very, very important reaction which is being used everywhere, and that is Ibrahim, could you help me out? What is the other method? Tell me, Ibrahim, for the preparation of phenol. Aisha, Marwa, can you tell me?
Cumin?
Yeah, cumene, exactly. Cumene hydroperoxide method. Cumene is a common name for very, very important reaction. So cumene is a common name for what? What is cumene, Aisha?
Is it isopropyl benzene?
Exactly. This is isopropyl benzene, right? This is isopropyl benzene. And you can react, and this is not only cumene, as the name indicates, hydroperoxide method. Okay, sometimes it is just told that the preparation of phenol by cumene, or this is the complete name of the process, hydroperoxide. So peroxide, as we know, is OO bond is known as peroxide. Hydroperoxide and cumene means H is there and cumene is there on the peroxide. So this is isopropyl and benzene. This is the cumene, and you have OOH. Got it? You react it with O2 in the presence of light or heat, and this oxygen get attached to this carbon, and then H is attached. So from here, from cumene, you get a peroxide on which has one side cumene, other side you have hydrogen, so cumene hydroperoxide. So this I hope is clear to all of you. Okay, the name. Ibrahim, are you there?
Yes, sir.
So what is cumene hydroperoxide? Tell me.
The cumene, it's an organic compound with three. What?
With what all groups? Just a little bit description you can tell me.
Okay, so cumene is what? Isopropyl benzene, yeah, because there'll be three methyl groups. No, two methyl
Yes.
groups and one CH. So we can
Now
do
that is isopropyl and benzene.
And if we oxidize it in the presence of light, so we'll get a cumene hydroperoxide. Yeah.
Yeah, peroxide is that O bond, single, right? And with hydrogen and cumene on the either side of that peroxide, in case of cumene hydroperoxide. Got it? Marwa, is it clear?
Yes, sir.
So you need to take isopropyl benzene, react it with oxygen in the presence of heat or light. You will end up with cumene hydroperoxide. Okay. Now what to do with it? But we were not aiming at hydroperoxide. We were trying to make phenol. Okay. So how to get that phenol? You heat it with concentrated H2SO4 or H2SO4. Sometimes it is just written as H plus H2O. It is one and the same thing, or H2SO4. With H2SO4, it undergoes rearrangement, and you have these two molecules. The one is acetone, and the lower one is phenol. This one. I have put box on them. Is it clear? So, Marwa, if I ask you what is the byproduct of cumene hydroperoxide method, will you help me out? Just try to figure out what is the byproduct which is formed along with the phenol. Tell me, Gauti.
Is it acetone?
Yes, acetone. Because everybody remember that phenol because it is the name, the cumene hydroperoxide method for the preparation of phenol. But most people forget this acetone. Okay. So do remember it, very, very important. Acetone is the byproduct of cumene hydroperoxide method. And how we are going to make it, just select this OH and benzene, and that part isopropyl and oxygen turns into acetone. So this is how the reaction is going to happen. Okay. So let me ask some questions. So what are A and B?
The chlorobenzene.
Pardon?
Chlorobenzene.
Yes, A is chlorobenzene. And what is B? Phenol.
And
Okay. Phenol, yeah, that NaCl that we are not going to write. This is the main product, right? Got it? Any doubts in the first part, this question? Jasleen, Marwa, Ibrahim, tell me. Okay, this P is what? I have just connected many parts of the question. So we can start working on them one by one. But they are not difficult. Very easy to understand. I have also put in some reactions from the previous chapter. Okay. So Ibrahim, what is P? Marwa, is it just what is P? And what the name of the reaction? Tell me. What is happening? ALC is the catalyst. Okay. Jasleen, Ibrahim. Ibrahim, do you remember what this is? His first reaction?
So I think the no, I think the chlorine will get separated and it will join with the benzene ring. I think.
Yeah, this isopropyl group will join to the benzene. This is alkylation of benzene. Okay, Fieldcraft alkylation. Is it clear? Alkylation, or the complete name is, the Cl will get removed by the AlCl3, which is a catalyst. This breaks the Cl. This isopropyl group is going to get attached to the benzene. Marwa, is it clear or not? Jasleen?
Yes, sir.
So this is, what's the name? Fieldcraft alkylation. This is alkylation of the benzene ring. Now you have Q. Got it? This Q will convert this isopropyl benzene to this compound. This is very easy. So what is the structure of Q? What this reagent Q is?
Yeah.
Very
Oxygen.
simple. Yeah, this is O2. So Q is O2 in the presence of heat or light. You can take H nu, you can write. This cumene will get converted to cumene hydroperoxide. And with concentrated H2SO4, you are going to get two things, R and phenol. What is R? Okay, you have this phenol and R. So what is R? Just now I asked you, what is the byproduct of cumene hydroperoxide method?
Acetophenone.
Acetone, right. This is acetone. Good. And once, what happens if you react acetone with LiAlH4, that we have seen in the yesterday's class. And in today's class also, in the beginning, we just had a quick recap of the previous class. Ibrahim, do you remember? What is S?
So after the reaction with P, what the thing? So,
Now,
so
R
where
is
did that
acetone.
come from? Because
R is acetone. What is S?
oh, okay, we
You
did.
have reacted
Okay.
R with LiAlH4.
No, no. So that will get converted to an alcohol. Yeah.
Yeah, this will convert into alcohol. It is isopropyl alcohol. Okay, you just don't put double bond O, make it single bond O. OH. Got it? This is the structure of S, right? Reduction. We have seen, Mara, Jasleen, in the today's class also. Next is this one. How can you convert this alcohol to alkyl chloride? This we had seen in the previous chapter. but both are interconnected. So you need to know what is the reagent T. Can you tell me? That will convert this OH to Cl. Can you make a list? Aisha, Ibrahim, Marwa, Jesslyn, can you tell me the list of the reagent which can convert the alcohol to alkyl halide? Ibrahim, tell me what all reagents we have seen in the previous chapter.
HCl.
Pardon?
HCl.
It could be HCl, very good. Yeah.
ZnCl2.
Yeah, HCl and ZnCl2, you can take the catalyst. Exactly. What other reagent which we can use to convert OH back to chloride? Previous chapter. Just a second.
SOCl2, I think, yeah. SOCl2 also.
Yeah, SOCl2 thionyl chloride. That was the best method, okay, to convert SOCl2 in the presence of pyridine. That was the best method to convert the alcohol to chloride. Okay, good. Next is I'm using putting or. You can use any one of them. Okay, you can use SOCl2. There were two other reagents. You know them. They had phosphorus in them. That's the hint. So they had phosphorus in them. What were the two reagents? They must have chlorine also, otherwise how the chlorine is going to come? So PCl3, PCl5, got it? Is it clear? Very important how to convert OH back to previous chapter alkyl halide. Don't forget the previous chapter. Ibrahim, can you recall these reactions?
Yes, sir. Yeah.
From the previous chapter, very important. So this is the preparation of alcohol, and the alcohols can be converted back to alkyl halide by HCl ZnCl2, that is Lucas reagent, SOCl2, that was SNI mechanism. Okay, or that is also one of the best method because the byproducts are sulfur dioxide and HCl, they escape on their own. Or phosphorus containing compound, there were two compounds. Okay, and those two compounds are PCl3 or PCl5. They can convert the OH to Cl. Okay. Let me ask you one more question. So let me write this question. Okay, yeah. Now it is okay. So what are A and B? A is very simple, direct. Jaslin, Mara, tell me what is A? A is what? Aisha need to check the approach is correct. The compound is category is correct, but the alkyl group you need to check once again. Which alkyl group we have taken with the Br. That only you need to put it. Got it? Marwa, tell me what is A? Jaslin, tell me what is A? So you have this alkyl group. Got it? As you are reacting this with Br, so Grignard will be of this compound. Okay. Is it clear or not? This is the structure of A. Jaslin, you have put one extra CH2. Check it. And Aisha, you actually missed some of the carbon. Okay, just write it. Don't write the shorthand representation, write it like this. Okay. Because that may cause some problem. Yeah. CS3 is 10 GBF. Got it? Clear to everybody? This is A. Now I reacted with B. And water. I ended up with this alcohol. So what is that B? We need to work backward to get the structure of B. No, Justine. No. That will give Aisha, that will give carboxylic acid. We are having an alcohol. So just try to figure out what we started with, what we had, and what extra was connected. Are you getting my point? So we had this much. We had this much, right? No, Aisha, right? This you agree or not? We have in A we are having this much amount. Okay, this much we are already having. Okay, is everybody agreeing with that? So now try to check what extra. Extra is this. You need to take this much portion with double bonds. Are you getting my point? Aisha, Ibrahim, Jasleen, Marwa. Are you getting this much? We were already having. Can you see? Do you agree with it? This was there in the Grignard. Now, in order to get the final product, what extra thing we are having? This is extra. So we can take the aldehyde or a ketone according to that extra thing. Okay. Are you getting my point? So what extra thing that was? That was CH2 double bond O. Is it clear or not? Ibrahim, have you understood? Aisha, Jasleen, Marwa? So what we are having, sometimes we forget the reagent. Okay. I have seen many students. So what you are having in the question, what is the final answer? Just compare what extra you require. So that extra portion, the reagent, you should think about that extra portion. So this was something CH2O. Okay, CH2O, when we will try to figure out what is that CH2O, that CH2O is CH2 double bond O. Got it? So that's how we try to figure out the missing reactant. Always try to compare the reactant which is given to you and the product. You can make them out. You can, by comparing, you can easily figure out what is the missing reactant. Okay, this is the trick which you can use for CBSE, definitely for CBSE, but not only for CBSE, in every examination. In JEE Advanced also, many students, there are a lot of big questions, okay, large questions, subjective questions, okay, paragraph based questions, multiple reactions. So there also you can, I always tell my student to follow the most simplest approach. Look for the reactant, what we are having, look for the product, try to compare what extra thing we need to put in. Okay, and accordingly you can choose your reagent. Is it clear or not? Okay, so let me do one more problem. Just you need to tell the direct reagent. So compare what we are having now. Compare what extra we need to put in the product. You have HNOH extra. This is addition of Ibrahim. This is addition of water. Got it?
Yeah, this of what?
Is it the Markovnikov addition with the H is going to the carbon atom where you add more H's? Or the H is going on a reverse direction?
No. Hydrogen is going to reverse direction here.
Reverse direction means it is anti-Markovnikov. And that
Yeah,
how it
so
is carried out. That is BS3 THF, right? THF is the ether which is used. This THF is the cyclic ether, right? So in the next class, we are going to start with the physical and the chemical properties of alcohols. Okay. That will include some physical properties, boiling point, acidic strength, okay, and chemical reactions, chemical properties, oxidation, all the reactions. Okay. So be prepared for it, because that is a very important part. Okay, do your NCERT intakes problems and the back exercise, right? They are very important for you. Okay, so I hope everything is clear in this class. So let me end this class, right? Just go through your NCERT. Okay, so by next week we'll be starting with the properties, physical properties, chemical properties, and this is the reactions which we covered